Welcome to the video. In this lesson, we're going to be looking at section 7.3, where we're going to be multiplying and dividing rational expressions. The first thing that gets asked to us here in the essential question is how can you determine an excluded value in a product or quotient of two rational expressions? So let's just look at one, for instance. So let's say you had a problem like x plus 2 divided by x minus 3, something like that. Okay. This is how it started. What you have to kind of do is say, all right, what what values in the denominator are going to be undefined? So again, when it becomes, we have to figure out what x has to be if it were to be equal to 0. And then, so basically what you're going to do here is you're just going to take the denominator, and this is x minus 3, set equal to 0. Figure out what x would be. So if I add 3 to both sides, x would equal 3. So if x were to be 3, this particular expression would be undefined because my denominator would be equal to 0. So an excluded value would be x could not equal 0. Or not 0, x could not equal 3. X could not equal 3 for this particular situation. So that is how you find an excluded value. You take the denominator, set it equal to 0, and then solve it. What we're looking at here today is we're trying to simplify an expression. So anytime we're going to try to simplify an expression, whether it's multiplication, whether it's division, whether it's just a singular fraction, we want to be able to cancel out as much as we can before we do any type of operation. So, we do this with, with numerical fractions all the time, like 15 over 65. Both of those values are, again, divisible by 5. You can just divide them by 5 and then get 3 over 13. Or you can do it like how it was done here. They broke it up into two products and found out that they share a value of 5 contained with multiplication. You're allowed to cross things out when it's contained within multiplication. Um, what I would try to do, especially when we're dealing with polynomials in numerators and denominators, is I'm going to try to factor things, and I want to try to get the exact same values in numerator and denominator, which then will cancel out. So, for example, they're asking us to simplify x squared minus 4x minus 12, and it's going to be all divided by x squared minus 4. So what we are going to do for this particular situation is we are going to factor both the numerator and denominator. So looking at the numerator, I'm going to go parentheses, parentheses. It's a simple trinomial, so it's x and x. Minus 12 tells me the signs will be different. One's plus, one's minus. The first sign is minus with the minus 4, so the large number is attached to minus. Two values that give me a product of 12, but their difference is 4, will be 6 and 2. In the denominator, I have x squared minus 4. Now, it's not a trinomial, but what it is a sum and difference pattern. So this can be factored out as x plus 2 times by the quantity of x minus 2. So now what I see is I see in two sets of parentheses x plus 2 in both the numerator and denominator. I can cancel those out to be 1. So now my simplified expression is going to be x minus 6 all divided by x minus 2. And this would be my answer. When it comes to multiplying, again, you're just going to multiply across. So you're going to multiply each individual numerator and denominator. So in this case, A and C are both the numerators. Multiply them across, it's A times C. B times D is in the denominator, multiply across, you got B times D. What I would ask you to do is, first off, I would try to factor as much as you can before you do any type of multiplying across for these particular problems. Sometimes you can, sometimes you can't, but again, you have to look at some of these by individual on an individual basis. So, for instance, if you look at this particular one, they want you to find the product, and I can't factor any of these. All right. So what I would do first is I would attempt to, since it's not overly um, taxing, I would just try to take, let's see here, if I took this one with a 2 and the 8, they're both divisible by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. But then I got a 4 here in the numerator and denominator. Both 4 divided by 4 is 1. Here, and this is 1. So the only numerical value that's not 1 in this multiplication problem is the 7. So I'm going to write in 7 on the outside. Okay. Now what I'm going to do is I'm going to take all of the variables and multiply them across. So x to the third times it by x to the fourth is going to be x to the seventh power because you can just add them. Y times y to the third is y to the fourth, and it's going to be divided by, that's nothing else with x, so it's just going to be x, and then y to the second times it by y is y to the third. So now that I've taken care of the numerical values, now I'm going to take a look at the rest of the variables now that there's less of them, there's less terms. And I have same base values of x and I have same base values of y, which I can divide. So now this is going to be equal to 7x to the sixth power, because 7 minus 1 is 6. And then it's going to be y to the first, because 4 minus 3 is 1. So my simplified expression of this product is 7x to the sixth y to the first. What I have here is a series of trinomials. So what I would like to do first is see if I can factor out each individual numerator and denominator. See if I can cancel anything and then multiply it across. So looking at the very first numerator, I have 3x minus uh, 3x squared. So what I'm going to do is I'm going to write in 3x, and on the inside it's going to be x minus, actually nope, it's going to be 1 minus x. Yep. When I look at the denominator, x squared plus 4x minus 5, I can factor that like so, x here, different signs, larger numbers attached to a plus in this case, and it's going to be 5 and 1. All right, so now I look here, looking at the top, x squared plus x minus 20. This can be rewritten as x and x. Different signs, large numbers attached to a plus in this one as well, and product of 20, difference is 1, is going to be 5 and 4. And then 3x I can't do anything with, so that is just 3x. So now I need to look at things that appear to be the same. So 3x and 3x, those can be 1s. X plus 5, that is also 1. Now, what I'm going to do for my next step is this. If you look at this x minus 1, it looks really close to, I'm sorry, to the 1 minus x. So what I'm going to do is I'm actually going to flip this top one here and say, okay, I'm not changing the signs yet. All I'm going to do is say, oh, this is negative x plus 1 divided by x minus 1 times it by x minus 4, because that's what I have left. Okay, it looks really close. Negative x plus 1 and x minus 1 look really close. So what I'm going to do now here is I'm going to factor out a negative 1 in that numerator. So now I'm going to put negative 1 on the outside. This now turns to x minus 1. And now I get x minus 1 on the bottom as well. So now that I have those the same, those turn into 1 as well. So now all I have left over is the negative 1 and the x minus 4. So you can write this as negative 1 over x minus 4 if you want to, or you can distribute the negative 1 and say that it's negative x plus 4. All right, either one um, I would accept. Either one I would accept. When it comes to division, when you are dividing fractions, kind of like what you did in middle school, remember, you're going to make it into a multiplication problem. The difference is the first fraction remains the same, a over b, make it into a product, but then you take the second fraction and make it the reciprocal. So if it was c, if it was divided by c over d, it's being multiplied by d over c. And then you would take care of the um, same things as you did as it was a multiplication problem. So again, keep that in mind. So for this one, it's division problem. What we're going to do is right off the bat, make it a multiplication problem. So I get 7x over 2x minus 10. It gets multiplied by x squared minus 11x plus 30 over x squared minus 6x. Once you make it into a multiplication problem, you factor each individual numerator and denominator. 7x, can't do anything with. I leave it at 7x. 2x minus 10, I could factor out a 2. So now I got 2 times by the quantity of x minus 5. It's being multiplied by looking at x squared minus 11x plus 6, parentheses, parentheses, x here, same sign. They're both going to be minuses. Two values give me product of 30. Sum is 11, 6 and 5. On the bottom, x squared minus 6x, I can factor out an x, and then this is going to be x minus 6. All right, let's see what I can cancel. I can cancel x minus 6. I can cancel x minus 5. I can also cancel x and x, because those can be 1s. What do I have left? I have 7 in the numerator and I have a 2 in the denominator. So my simplified, in this case, division problem is 7/2. So one more quotient. This one here, you have a fraction divided by nothing, something that's not a fraction. Anytime that is the case, again, leave this the same. You are still going to make it a multiplication problem, but instead of 3x squared plus 5x, it's going to be 1 over 3x squared plus 5x. And then you're going to take care of um, the factoring. Now, what I notice is this. This 6x squared plus x minus 15, that's a complex trinomial, all right? So what I believe is, let's try to factor out things that are easier to factor. So right now, 1 is going to remain the same and 4x squared is going to remain the same. It's easier to factor out 3x squared plus 5x than it is 6x squared plus x minus 15. So when I look at that, I can factor out an x. So it looks like what's left in here is going to be 3x plus 5. All right. Why is that helpful? Well, when I come to factor this, I know that the signs are going to be different. I know that the product of the two numbers in front are going to give me a product of 6. And I know the values in the last terms are going to give me a product of 15. But because I have this 3x plus 5, I am going to make an educated guess and say I'm probably thinking that 3x plus 5 is going to get canceled out. So what I'm going to do is with that kind of that hypothesis, I'm going to say 3x plus 5 is going to be one set of that parenthesis. So which means the other set is going to be 2x minus 3 because 5 times 3 is 15. 3 times 2 is 6. And let's see if it comes out to be positive x. So this is um, negative 9, and that's positive 10. So yeah, so because 3 and 3 give me negative 9, 5 and 2 give me positive 10 minus 9 is 1. So it makes sense. So I was correct in my assumption. Those two are going to be canceled. And that appears to be everything that can be canceled at this point. So when I multiply it across, I have 2x minus 3 all divided by 4x to the third. And I can't cancel anything else out because the x in the numerator is contained by subtraction in this case. And that is being able to multiply and divide rational expressions. Hope this helps. Until next time.